The purpose of this video is to distinguish between two things. Probability on the one hand, which is sometimes referred to as probability mass, and on the other hand, probability density. So let's begin by thinking about this concept of probability density. And let's start off with something you're probably all familiar with, a normal distribution. So we get a nice normal distribution, and let's give it a mean here at 100. And let's look at some value here at 115. So when y is equal to 115 on the horizontal axis, we pull this across and look at the y-axis, the vertical axis. Well, what do we see over here? Is this the probability? Is that the probability that the value of y is equal to 115? No, it's not. And the reason it's not is that if we've got a normal distribution, we're dealing with a continuous distribution. And the whole idea of a continuous distribution is that between any two values, there will always be the possibility of having a third. So if we think about what's the probability of getting exactly a value of 115, that's going to be equal to, even though it's quite counterintuitive, it's going to be equal to 0. So that's not terribly helpful. How are we going to get around this problem? Well, you've got in your lecture notes a figure that looks like this. And what we have is down here on horizontal axis, we've got different values of the random variable y, and it goes from about 40 to 150. And each one of these dots represents a separate observation. And there's 1,000 observations, and I've just put in a little bit of scatter to make it easy to see. So let's think about this value that's associated with 115. And what I've drawn here, there's the 115 right there. And on one side, I have 114 as a thick vertical line. And here, a slightly thick vertical line, we have 116. Now we consider this little rectangle here. It captures all the values between 114 and 116. Well, we can calculate the probability of a value lying between 114 and 116. That's easy to do. We just count up the number of points that lie between 114 and 116 and divide by the total number of points. So that'll give us the probability that our value lies between 114 and 116. So that's probability. And technically, we often refer to this as probability mass. Although most of the time we'll drop the mass and just refer to it as probability. And this is what we're typically interested in when we think about discrete variables. But now we got to think about our continuous variable. How are we going to get some value? How are we going to get this value out here that's associated with 115? Well, what we're going to do is we're going to think about all the points inside this rectangle. And we're going to take the number of count of points inside that rectangle, and we're going to divide it by the distance between 114 and 116. And the value that was obtained by taking the probability mass between 114 and 116, dividing it by the difference, 116 minus 114, as that distance between 114 and 116, if we were to shrink that distance, as that distance becomes infinitely small, the probability mass divided by that distance will be equal to the probability density. So now if we come down here and look at a normal distribution, we now can understand what the heck this value here means. What does that number mean? Something between 0.005 and 0.010. is that I can draw a thin line centered on 120. And on either side, I've got these longer vertical lines. And this value here, between 0.005 and 0.010, is obtained by taking the probability of lying in this region between those two lines, dividing by the distance between those two lines as that distance becomes infinitely small. Now, the terminology can get a little bit confusing. And we'll do P at Y in this workshop as the probability distribution. And the thing to remember is that if we're talking about a discrete variable, we're going to be thinking about probability mass. Although we usually won't use the word probability mass, we'll just use probability. And if it's continuous, we'll be talking about the probability density, which again, as a review, is just the probability mass divided by this distance as that distance becomes infinitely small.